Hello everyone, welcome to Hershey class. I am Rani. Today I will explain you about the test for divisibility of numbers, which is given in Class 6 NCERT Mathematics, Chapter 3, Playing with Numbers. Test for divisibility of numbers. What are the uses of these divisibility tests and how to do it? Divisibility tests help us to find whether a number is completely divisible by another number without leaving any remainder. We can find it by using with the help of divisible test. For example, 38. 38. Is it completely divisible by 2? Or 38, is it divisible by 5? We need to check that. How to check? By doing the division. Instead of doing the division, we can identify the divisibility of a number by examining the digits. For the ones place digit, or by examining the tens place digit, or by the sum of the digits of the given number, we can identify the divisibility of that number. Let's say few divisibility tests. So number, test of divisibility, and few examples also given here. We will discuss those examples. First number is 2. You know that the number 1, about number 1, that every number is divisible by number 1 completely without leaving any remainder. So I am not mentioning that number 1 here, starting from number 2. 2. Test of divisibility is that a number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its ones place. The numbers which are ending with 0, 2, 4, 6, 8 are called even numbers. That means all the even numbers are completely divisible by 2. All the even numbers are completely divisible by 2. Examples: 16. 16 divided by 2 is equals to 8. Here 2 can divide 16 without leaving any remainder. 2410 ending with 0, so it is also divisible by 2. 1358 is ending with 8, it is also divisible by 2. If you divide 2410 with 2, what will be the question here? 2410 divided by 2. 2 ones are 2. Remainder 0, 4 will come down. 2 twos are 4. 0, 1 will come down. So 1 is not divisible by 2. We will put 0 over there and take this 0 down. 2 5s are 10. Remainder 0. If you divide 2410 with 2, we will get 1205 as the quotient and remainder 0. Next, 1358. It is also an even number, completely divisible by 2 without any remainder. The quotient of 1358 divided by 2 is equals to 679. It is 679. Next, 3. If the sum of the digits is divisible by 3, then the number itself is divisible by 3. So here we need to add the digits in the given number. For example, 54. 5 plus 4 is equals to 9. Now the sum of the digits is 9. 9 is divisible by 3. 3 3s are 9. So 54 is completely divisible by 3. 219. Next example, 219. 2 plus 1 plus 9. 2 plus 1 3. 3 plus 9 12. 12 is divisible by 3. 3 4s are 12. Next number is 7200. 7200. 7 plus 2 9. If we add 0, then also we will get the same number. 9 is divisible by 3. 3 3s are 9. So all these three numbers are divisible by 3. For this, we need to add the given digits in the number. Sum of the digits is divisible by 3, then the number itself is divisible by 3. Now, number 4. Number 4 test of divisibility is a number is divisible by 4 if the last two digits of the number are divisible by 4. Here we need to check the last two digits of the number. Okay, in case there is only two digits in the number like 56, so we need to check that those two digits are divisible by 4 or not. Simple. 56, is it divisible by 4? 56. 56 is completely divisible by 4. 4 ones are 4. 4 fours are 16. So 56 divided by 4 is equals to 14. 212. Check the last two digits. 12. 12 is divisible by 4. 4 threes are 12. Now 212. If you divide 212 by 4, 4 fives are 20. 4 threes are 12. 53 will come. 3516. 16. Last two digits are 16. 4 fours are 16. So it is also divisible by 4. Another thing is that if any number is ending with two zeros, that is also divisible by 4. For example, 1500. It is ending with two zeros. So it is also divisible by 4. 1500 divided by 4. 4 threes are 12. 4 sevens are 28. 4 fives are 20. 375 will be the quotient. If you divide 1500 by 4, 375 will be the quotient. So 4 can divide the numbers which are ending with two zeros without leaving any remainder. 700. 700 is also ending with two zeros. In its ones place and tens place there are zeros. Let's check. 4 ones are 4. 4 sevens are 28. 4 fives are 20. 700 divided by 4 is equals to 175. So the divisibility test here is we need to check the last two digits of the number, that is ones place and tens place. If the two digits are divisible by 4, then the number is completely divisible by 4 without leaving any remainder. Or the number is ending with two zeros, then also it is divisible by 4. Next, number 5. Number 5. A number is divisible by 5 if it has either 0 or 5 in its ones place. Example 65. 65 is ending with 5. So it is divisible by 5. 65 divided by 5 is equals to 5 ones are 5, 5 threes are 15. 13 will come. 125 ending with 5. So it is also completely divisible by 5. 5 twos are 10, 5 fives are 25. Next 3200 ending with 0. Ending with 0. So it is also divisible by 5. 3200 divided by 5 is equals to 5 6 are 30. 5 fours are 20. 0. 640 will come here. Number 6. If a number is divisible by 2 and 3, 2 and 3 both, then it is divisible by 6 also. So, the divisibility rule of number 2 is that all the even numbers are divisible by number 2. Even numbers ends with 0, 2, 4, 6, 8. Number 3. Divisibility rule of number 3 is that sum of the digits in the given number should be divisible by 3 without leaving any remainder. Or The sum of the digits in the given number should be a multiple of 3. Examples: 2430. 2430 is ending with 0. So it is an even number divisible by 2. Now check with 3. 2 plus 4 6, 6 plus 3 9, 9 plus 0 9. 9 is a multiple of 3. It is completely divisible by 3. So 2430 is divisible by 6 also. Next number 1356. 1356. It is ending with 6. 6. So it is an even number, completely divisible by 2 without leaving any remainder. Now check with 3. 1 plus 3 4, 4 plus 5 9, 9 plus 6 15. 15 is a multiple of 3. 15 is completely divisible by 3. So 1356 is also divisible by both 2 and 3. That means it is also divisible by number 6. 7. Number 7. Test of divisibility is that double the last digit of the number and subtract it from the remaining digits of the number. If the difference is 0 or a multiple of 7, then the original number is also completely divisible by 7. This rule is a bit tricky. Practice is required for this. Here the number is 693. The last digit is 3. Double the digit. That means 3 plus 3 or 3 twos are. Double the digit. So you will get 6. If you double 3, you will get 6. Subtract this from the remaining digits. Remaining digits in the number are 69. So 69 minus 6 is equals to 63. 63 is a multiple of 7. 63 is completely divisible by 7. 7 nines are 63. That means 693 also divisible by 7. Next example, 2450. 2450. Here the given number is 2450. What do we need to do? First, separate the last digit. Separate the last digit. So 245 will be there. 0. If you double the 0, then also you will get 0 only. Subtracting 0 also give 245 only. 245, is it completely divisible by 7? It is a bit tricky to find the divisibility of the greater numbers by using this test. Then what we will do? We will continue this process. We will repeat the process. Now we got 245. Again, you can repeat the same process, entire process with 245 again. 245, here the last digit is 5, double the 5. 5 twos are 10. Subtract that from 24. 24 minus 10 is equals to 14. 14 is completely divisible by 7. 14 is a multiple of 7. So 2450 also divisible by 7. Here we can repeat this process. We can repeat this process until we get the 2-digit number. Until we get the difference 2-digit number like here 14. You can repeat this process. It is a bit tricky one. Practice is required for this one. Number 8. A number is divisible by 8 if the last 3 digits of the number are divisible by 8 or last 3 digits are zeros. Here we are going to check the ones place, tens place and hundreds place digits in the given number. If those 3 digits are divisible by 8 without leaving any remainder, then that number is completely divisible by 8. For example, 13,408. Here the last three digits are 408. 408, is it divisible by 8? Yes, it is divisible by 8. 408 divided by 8 is equals to 8 5s are 40, 8 1s are 8. 51 will come. Remainder 0. That means 13,408 is also divisible by 8. Next number 7,216. 216. Let's check 216. Is it divisible by 8 without leaving any remainder? 8 2s are 16. 5 56. 8 7s are 56. So 216 divided by 8 is equals to 27. It means 7,216 also completely divisible by 8. If the number is ending with 3 zeros, then also it is divisible by 8. For example, 1000. 1000 is ending with 3 zeros. 3 zeros. So it is completely divisible by 8. 1000 divided by 8 is equals to 125. Next example, 23,000 ending with 3 zeros. Divide it with 8. 8 2s are 16. 7 0. 8 8s are. Then 8 7s are. 2,875 will come. If you divide 23,000 by 8, 2,875 will come and remainder 0. Next number 9. If the sum of the digits of a number is divisible by 9. This rule also same like number 3. Like number 3. Sum of the digits. Here also we are going to check the sum of the digits of the number. 27. We know that 27 is a multiple of 9. So it is completely divisible. Right. 2 plus 7 is equals to 9. 9 divided by 9 is 0. It is divisible by 29. Next 4,608. 4,608. 4 plus 6 10. 10 plus 8 18. 18 is divisible by 9. So 4,608 is also completely divisible by 9 without leaving any remainder. This rule is similar to number 3. Number 10. If a number has 0 in the ones place, then it is divisible by 10. Examples 3,200. 0 in its ones place. So it is completely divisible by 10. Quotient will be 320, remainder 0. 7,010. 0 in its ones place. Here quotient will be 701, remainder 0. 60 also ending with 0. So it is also completely divisible by 10. Remainder 6. Number 11. If the difference between the sum of the alternate digits is 0 or multiple of 11, then the number is divisible by 11. Here first we need to find the sum of the alternate digits. First step is that we need to find the sum of the alternate digits. Then second step, find the difference between those two sums. If the difference is 0 or multiple of 11, then that is divisible by 11. Two examples are there. 1,331. Here 1,331. First find the sum of the alternate digits. Alternate digits, first position, third position numbers. First and third place numbers I am going to add now. 1 plus 3 is equals to 4. Now I will add the number which is in the second place and fourth place. 3 plus 1 is equals to 4. Now we know the sum of these alternate digits. Next step is find the difference between them. That is 4 minus 4. 4 minus 4 is equals to 0. Here difference is 0. So 1331 is divisible by 11. Next example, 61,809. 61,809. First add the alternate digits. First position 6 is there and the third position number is 8, 4. After that fifth position 9. First, third and fifth digit. I am going to add these three digits first. 6 plus 8 plus 9. 6 plus 8 plus 9. 6 plus 8 is equals to 14. 14 plus 9, 23. Now add the numbers which are in the even positions. That is second position and the fourth position. 1 plus 0. 1 plus 0 is equals to 1. Now we know the sum of these two, sum of the alternate digits. Let's find the difference between these two sums. 23 minus 1 is equals to 22. 22 is a multiple of 11. 22 is a multiple of 11. 11 2s are 22. 22 is completely divisible by 11. It is a multiple of 11. So 61,809 is also completely divisible by number 11. Number 12. If a number is divisible by 3 and 4 both, then it is divisible by 12 also. Divisibility rule of number 3 is that sum of the digits in the given number should be divisible by 3 or that sum should be a multiple of 3. 4. We need to check the last two digits of the given number. If the last two digits are completely divisible by 4 without leaving any remainder, then it is divisible by 4. Then the complete number is divisible by 4. 1092. 1 plus 0, 1. 1 plus 9, 10. 10 plus 2, 12. 12 divided by 3 is equals to 4. So 1092 is divisible by 3. Let's check with 4. Last two digits are 92. 92, 4 2s are 8. 4 3s are 12. 92 is completely divisible by 4 without leaving any remainder. That means 1092 is divisible by number 12 also. 1716. 1716. 1 plus 7, 8. 8 plus 1, 9. 9 plus 6, 15. 15. 3 5s are 15. 15 is divisible by 3. Let's check with 4. Last two digits are 16. 4 4s are 16. So 1716 also completely divisible by number 12. Next one, number 15. If a number is divisible by 3 and 5 both, then it is divisible by 15 also. Divisibility rule of number 3 is that we need to check the sum of the digits. If the sum of the digits in the given number are divisible by 3, then the complete number is divisible by 3. 5. If any number ending with 0 or 5, that means 0 or 5 in its ones place, that number is divisible by 5. First one, 375. 375. 3 plus 7, 10. 10 plus 5, 15. 15 is divisible by 3. So 375 is divisible by 3. Let's check with 5. It is ending with 5. That means this number is also divisible by 5. So 375 is completely divisible by 15. Next example, 4395. Sum of these digits are 4 plus 3, 7, 7 plus 9, 16, 16 plus 5, 21. 21. 3 sevens are 21. 4395 is divisible by 3. And also it is ending with 5, means it is divisible by 5 also. 4395 is completely divisible by 15 without leaving any remainder. Some more divisibility rules. There are 4 more rules. First one, if a number is divisible by another number, then it is divisible by each of the factors of that number. For example, 18. 18 is divisible by 9. 18 is divisible by 9, so that we will get question 2. So now 18 is also divisible by the factors of 9. What are the factors of 9? 1 9s are 9, 3 3s are 9, 9 1s are 9. 18 is also completely divisible by the factors of 9 without leaving any remainder. Divide and check. 18 divided by 1 is equals to 18, remainder 0. 18 divided by 3 is equals to 6, question 6 and remainder 0. 18 divided by 9 is equals to 2, remainder 0. Next rule, if a number is divisible by two co-prime numbers, then it is divisible by their product also. Here two co-prime numbers. Co-prime numbers means the numbers which have only one as a common factor. For example, 4 and 5. The factors of number 4 are 1 4s are 4, 2 2s are 4, 4 1s are 4. Factors of number 5, 1 5s are 5, 5 1s are 5. What is the common factor? Common factor means the factor which comes in the factors of both the numbers. Here 1 is the common factor. 1 is the common factor. We know that the numbers which have only two factors, those are called prime numbers. The numbers which have more than two factors, those are called composite numbers. And the numbers which have only number 1 as a common factor, those are called co-prime numbers. Here 4 and 5 are co-prime numbers. Example, the number 80. 80 is divisible by 4 and 5. 4 and 5 are co-prime numbers. 80 is divisible by 4 and 5. If you divide 80 with 4, 20 will be the quotient and remainder 0. If you divide 80 with 5, 16 will be the quotient and remainder 0. That means 80 is completely divisible by 4 and 5. 4 and 5 are co-prime numbers. So it is also divisible by the product of these two co-prime numbers. Product of these two co-prime numbers is 20. 4 5s are 20. 80 is also completely divisible by 20. Next rule, if two given numbers are divisible by a number, then their sum is also divisible by that number. 16 and 20 are both divisible by 4. Example, 16 and 20. 16 is divisible by 4, 4 4s are 16. 20 is also divisible by 4, 4 5s are 20. So, their sum is also divisible by 4. 16 plus 20 is equals to 36. 36 is also divisible by 4. 4 9s are 36. Next rule. If two numbers are divisible by a number, then their difference is also divisible by that number. If two given numbers are divisible by a number, then their difference is also divisible by that number. Example, 35 and 20. 35 and 20 are both divisible by 5. 35 divided by 5 is equals to 7. 20 divided by 5 is equals to 4. So, their difference is also divisible by 5. Difference between 35 and 20 is 15. 15 is also divisible by 5 without leaving any remainder. These are the rules of divisibility. Thanks for watching. Like, share and subscribe to my channel.